Okay. Okay, good. So, hi everyone. Um, my name is Tami. I'm based in Quebec, Canada, and um, and I'm going to present this project on a greenhouse challenge uh, we uh, we ran last year with the kids. So, just to give you some context, um, we have been running this. What we call Club Techno for about 3 years. And for about a year, we are a full-fledged Fab Lab affiliated to the Quebec Fab Lab network. So we run classes, coding, 2D drawing, 3D modeling, robotics, how to use a laser cutter, how to use a 3D printer. So throughout the year, um, but we also have special projects, and that's what I'm going to be presenting today. So this special project ID started about 3 years ago. We did run the future City of the Future project, and it was a success. The following year, we did the Make a Composter, and this last year we did have the greenhouse challenge, and I must say, every time it's a success. The kids are really engaged, and you can find all these projects on this portal called Our Canada Project. If you want to know more about the last project, but this today I'm going to focus on the greenhouse challenge. The slides are in French, and I'm going to present them in English. This is basically the blurb the parents got, inviting them to register the kids to this challenge. It basically says that your kid has to be 8 to 12. The project is considered like easy level. The curriculum alignment is aligned with math, science, and French. And the SDGs that we're going to be touching are 2, 11, 12, 13, and 15. So based on this information, the parents basically registered their kids, and we started. So the plan was, fairly simple. On day one, I covered the challenge. What is the challenge about? What are the 17 uh, SDGs? What's on about energy? Why we need to be careful about energy. On day one, basically, the kids, are presented with this process. So it's a house, obviously, and the second stage is they have to actually build it. Um, I wasn't sure if we were going to go down the cardboard uh, or 3D Tinkercad solution. And finally, um, they would present it using Scratch. And this was the first. So the 17 SDGs are in the 3, 4, 10, 11, and our project is 2. This is like one meeting with evaluation criteria, how the kids are going to be, how their projects are going to be evaluated. I think this is important. They know what's the expectations right fairly early on. And then we discuss the climate challenge they want to deal with, and we talked about the Scratch presentation. What is expected from them. So this the grade. So they get 60 points for the model or virtual or on the Tinkercad, and 40 points for the actual oral presentation. And this is the same evaluation rubric that the juries use at the end of the project to evaluate the projects. This is the climate challenges we're facing. So there's issues with water, shortage of water, pollution. There's energy, solar, wind energy. Talk about energy efficiency, and then the issues with earth and biodiversity. So some videos we watched together explaining what are the issues we faced with. And about the presentation, I've used this coding for climate material to explain what was expected from them. So basically, what they do with this in this coding for climate project, they actually make a model, take a picture, and then take it into Scratch, and the kids make a presentation with Scratch. So this is on day 2. On day 3, we start constructing the actual model, building the house. We talk about scale, colors, and we start discussing, presentation. What is it they need to talk about when they will be presenting to the jury. This is a 6 weeks project, so it's very quick. So these are some examples of the models. So we start with the no-tech approach. So they get these printouts and they just cut out and fold and glue together. These are very tiny, maybe 2 inches by 2 inches each. And they get a feel of what is a model, windows, doors, roof. So right from there, they start making their own, and you see on the picture some of the models they came back with from the following meeting, cardboard models of houses. But the low tech, we take it the next level. So within the cardboard model, we put some a LED, some copper, and a battery, and that is triggered with the doorknob. So when they open the door, the light goes off, and then when they close the door, the light goes on. And with that ID, we explore right away the possibilities in terms of presentation, so they can take a picture, and using a paint-like tool, they can enhance the model by putting solar panel and then taking it into Scratch to do the presentation. So they start, seeing what's the process like. The high-tech end was these models, but these were too expensive for us. So some of the kids had already received Tinkercad training, some didn't. So we did some. I created a Tinkercad classroom that they could join from home, and I can monitor their work. And basically in Tinkercad, they got an envelope that they could add solutions to it. So you got 2 examples, Sami and Ibrahim, adding to that Tinkercad model, wind turbine and solar panels, and they can be very creative, like this device to remove the snow automatically. Now, interestingly, they all went with the Tinkercad models instead of the cardboard models, and this is how at the end they would use Scratch to actually create an interactive presentation. How are we doing with time, Jamie?
You've got 11 minutes still.
Okay, plenty of time. So, this is actually a live example that you can go and check on Scratch project, where you could interact with a model. I'll try to do a live demo of that in a minute. Okay, let's see if this works. So yeah, so this is the one of the kids project. So if I enlarge and run the scratch, so they've created these little spheres, and if you click on them, it explains what this part of the model does. Um,
Malgré peu avoir une éolienne à terre, l'émetteur va consommer l'électricité grâce à l'énergie du soleil.
okay, so it's actually not only.
L'éolienne utilise la force du vent pour produire de l'électricité propre.
I don't know if you hear it.
Servent à séparer les différents de déchets communaux lorsque le vent se déchets et entraîne.
Yeah, so it actually writes in the bubble, but also speaks out the description of each device. So if I go back to okay, the beauty of using Tinkercad is also I was able to deliver badges as they went along in creating their model. And on June 29th, so as I said, we started in May. At the end of June, the kids were ready to share their projects and give the presentations. We try to make it like a little celebration, and we've been doing this for every special project every year. So we invite people from outside to be jury, and the kids stand up and present their scratch project. So these were the winners. So the kids were free to work on their own or in groups. This is the second prize. This was Sami, very creative with this device that removes the snow and holds it in the air and then melts it and then you store the water to use it in the summer. And then finally Melina also got a prize. So I started with 9 kids and finished with 5, but that's common. And the project was very successful, and I entered it into this Coolest Canada project competition, and this was fairly recent. On November 22nd, we were invited, and we got a prize there. And for that particular event, with the three kids here, we went a step further, where we used the microbit. It was the topic of the keynote, and we coded the microbit using Scratch to operate a wind turbine. And to do this project, we used a Lego EV3 motor, and they used pieces of Lego that were sitting around in the Club Techno, and to build a tower. And they could, using Scratch, start it and stop the wind turbine. So the event was hosted by Digital Moment, and we were very excited to be part of this event, and that certainly the kids really enjoyed it. So this is in a nutshell the project. And if you want to know more about what we do at Club Techno, there is this web link here. It's a Google Sites, and we put all our projects there. And this one in particular has a dedicated page. Yeah, the site is in French, but yeah, yeah. So this is the the input, the entry to the Canada Coolest project of the Greenhouse Challenge. And these are all the slides of the presentations that were given to the kids. This is and this is a little video of the actual wind turbine working here, and you have additional resources available here. So yeah, this is it. This is it. So if you have any questions, I can talk more about all the things we do at Club Techno, but I'll take first questions about this greenhouse challenge.
Yeah, we have about 2 or 3 minutes for questions. So does anyone have any questions for Tami? I'm wondering about your makerspace or Fab Lab. Is it open to the public, or is it for specific schools?
It's within a community center, so it's open to the uh, people from the community center. But when we organize special events, and it's open to the public, like we did an install fest last month, and people were welcome to come in with their laptops to replace Windows with Linux. Um, and we also last summer had this e-bike project where people could come in, convert their regular bike into an electric bike. So yeah, on special projects we open to the public, and yeah, that's it. Yeah.
So we have a question from Emma. Emma's asking, did the kids follow all the days, or could they just join for one day of the program?
No, they had to be here all along. As I said, we had 12 registrations. On day one, only 9 showed up. And at the end of the journey, only 5 completed the work, 3 groups, and they were free to work individually or in groups.
Great, very inspiring.
Good. I'm glad.
Thank you, Tami. Thank you very much.
Very